Good afternoon, everyone. My name is Dominic, and let me just quickly share my screen first. Just a moment. Can you see my screen?
Yes, I can see your screen.
Okay, great. So, yeah, today I'm going to talk about the connectors. Let's try to understand a little bit deeper about the connectors used in our application for electric two-wheel and three-wheel vehicles. So let's start with the introduction, basic understanding. So what are connectors? They are electromechanical devices used to join electrical conductors in an electrical circuit. So as you know that there are lots of connectors everywhere. Even at your home, you see on your TV appliances, even in your laptop computers, you have the USB there, HDMI, the power socket. So these connectors are mainly used for integrating systems. Like, for example, your phone, once the battery is depleted, you can charge it using the charging port that comes with it. A charging power system will then connect to a phone, which is basically a computer system. So we are integrating two electrical systems together. That is a basic understanding of a connector. So the main core part of a connector is the conductors, as you can see right here on the page. So the one on the left is a male pin. The one on the right is a female pin or female socket. So these are made of metal. They are copper alloys, which is then assembled into a insulator. So what you see here lower left is what we call a hybrid waterproof connector. Hybrid waterproof connectors are commonly used in a lot of different electrical vehicles because it's a hybrid, because lots of these vehicles are smart systems where they need to integrate power and signal together into a one connector. So the signal is used for communications. So sometimes we have, like, for example, a CAN bus protocol integrated into the system. So a power and signal uh, is the main components of this connector. And then, as you can see, the connectors are being used, and it is made up of plastic. This insulates each of these metal components. This becomes waterproof because it is needed for vehicles when they use it outdoors. And then it is equipped with gaskets, as you can see right here. Okay. And on the right side here, you have a one set of connector components. One goes into a panel, or what they call a receptacle connector. A panel sometimes is used on a end cap of a battery, for example. So this connector goes into, it is screwed on the battery, and it should also be equipped with a gasket for a sealing component. We need to make sure that no water can enter the battery itself. And then, of course, the plug. Once they're mated together, there should be no water intrusion in between the pins. Okay, so I just want to show you how these connectors are used in this application. Specifically now, as you can see, there's a scooter here. The picture on the left is a charging system. This one is the charging port that goes outside the vehicle. Sometimes it has a door or a cover to cover it and cover it up. And then, of course, the charging port, which in this case, this is a Type 6 charging gun. So this happens outside the vehicle. The one on the right is more on in the internals, where you can see there's the motor, the control unit, and the battery. The battery here consists of two connectors. Once the motor is being used, it draws power from the battery, making this one connector is a discharge connector. The one on the left is a charge connector. As you can see that it is connected into a charging port, and then the charging plug is then connected to the power socket. So this is just a basic representation of how connection systems are in a vehicle. But then there are more complicated things that when we go deeper, you see that there are more connection options there. Sometimes they include USB charging ports for so that you can charge your devices while using the vehicle. And then there are options like batteries goes up until 5 different batteries. Uh, and then connection systems, we need to have these all batteries connected with each other. As you can see here, this is the cable routing and organizations on this picture. All these connectors connected into a single junction box. So this type of connector is a different kind. It's a rectangular shape, which we call a floating connector, which we just use this as like a simple connection technology that I can be showing you later on. Okay, what are the common requirements for a connector for these application? Firstly, that these connectors need to be a high current rating. It doesn't need to be very high. We just need to know the requirement for the vehicle. So depending on the battery capacity, for example, and also the power of the motor, and then what are the peak currents that the vehicle is going to experience once you're using it. So from these aspects, we will be able to know what is the connector's current carrying capacity needs to be undergo. Then we can choose the correct connector. The second one is the reliability in a vibrating environment. Vibration can greatly degrade a connector's performance over time. So there's this phenomenon we call fretting. So if we go back to that page here, these pins are, once you remove the connector, these pins are removed. But once you lock the connector in place, these contacts should not move. But once fretting occurs in high vibration, there will be still such small movements in those micro vibration situations that may scrape off some of the plating on the surface of the contacts or the pins, and then once it scrapes off, corrosion may occur that we don't want. Okay. The third one is temperature rise. Okay, different temperature rise needs to be considered because, as you know, um, these conductors are made of metal and usually copper alloy with platings. These are malleable materials where in thermal expansions, temperature increases, it makes the metal softer, thus electrons flow slower. This results in increasing the conductor resistance, which we don't want. Okay. Waterproof rating is important because these vehicles are being used outdoors, sometimes in rain, sometimes there are conditions that there are floods involved there. So we don't want water to enter those contacts or even on the cable sides. So this can cause corrosion over time and also lowering the insulation resistance, and it can cause shortages as well. Of course, water is a conductor of electricity. So an example of this is an IPX7 rating for waterproof. So there should be no water intrusion under 1 meter of water in 30 minutes, for example. It's a testing method. The fourth one or the fifth one is easy to lock and unlock. This is much more considered in the user experience point of view. So there are a wide range of people using these connectors. So we need to make sure that even a lady with the smaller hands will be able to use this connector without any difficulty. Okay. High mating cycles. Okay. A mating cycle is equals to one plugging and one unplugging. Depending on the battery life, for example, the battery can last for 5 years. So the connector needs to meet its usage in that duration. Okay. So these two here is something that has been added recently. One point is that the connector needs to be compact so that you can carry it around, put it under the trunk of the vehicle so that you can easily charge it everywhere. And something that can save space will be a good point. And then more and more, this is becoming important point where the pricing of these connectors needs to be competitive because now these motorcycles becoming more higher cost than a traditional internal combustion. So cost is becoming more sensitive for future developments. Let's talk about key characteristics. There are three systems here that we're going to talk about. First system is about the charging system. As you see here, there are two connection pair. The one on the left is the charging port. Charging port is located usually outside the vehicle where there will usually have a cap or a cover. Okay. And then the one on the right is the charging plug. This is where user will be more, it's being handled more by the user. So once it's being handled more by the user, you need to make sure that the reliability of different people handling it differently um, needs to be durable enough. For example, because this has a cable, sometimes cables going into something like a connector, there are weak points, like for example, in this area here, where the bending, most of the bending occurs. So we need to consider some design ideas where we can put a strain relief to increase or increase the flexibility so that we don't have that much stiffness breaking the pins or the wires inside. And then the safety features needs to be considered. Like for example, here this connector is rated in like it's rated IPXXB, where there's a finger access protection. These connectors have some exposed metals that we don't want to be um, holding on by our fingertips, for example. Okay, there are some problems in these charging connectors where sometimes the wire breaks, like what I was telling you about. There are weak points on the connectors and jacket of the cable breaks. So to confirm that these connectors are performing pretty good in durability is that we need to have some standard compliance. Just an example about this is an IEC 60335, where these are subject to different types of testing. So if you see here, this is what we call cable rolling. Okay, you roll the cable on a low bend radius. The other is bending while inside the chamber. So this confirms that even in low temperature, because they are plastic flexible metal, plastic flexible material, sometimes it tends to break easily or become brittle in low temperature. So we need to confirm that in these tests. And of course, different tests like bending and then having some loads there. And then this swings back and forth to make sure that it has this good bending performance. And of course, the mating cycles, like I was telling you about earlier. You need to have a good mating cycle to make sure that this will work in the lifetime of the battery of the vehicle or the vehicle. Okay, the other system will be the connection of the battery system. The one on the right side here is the panel connector that goes to the battery. There are some features that it has, for example, this high performance connector pins or socket. It needs to have a high conductivity and high mating cycles and also withstands vibrations. It has a locking feature so that it stays always locked in place. The one on the left is the charging plug because since this is a battery connector, usually the battery sits below the seat, for example, and below the seat you don't have much hand access or finger access. So you need to consider ergonomic designs where there are, for example, here you see there's a tab that you can easily unlock this plug with only one finger. And of course, it needs to be waterproof, having the seal right there. And safety is another key component for finger access protection. So these problems occur. I just wanted to show you. Sometimes the contact fails. They tend to become loose. These needs to be tested. Sometimes connectors burns up because they do not meet the requirements I was telling you earlier. The others, like plastic, are breaking up. So there are confirmatory tests that we can do about this. Like, for example, a battery drop test, like this one right here. The battery actually has a connector below. We try to drop the battery with its full weight so that making sure the connector doesn't break. Or there are these situations where a user might pull out the cable itself. So these tests, confirmatory tests, make sure that the connector is durable. Of course, the vibration is here as well, the vibration testing. So to design a battery, it needs to be able to have a good protection on the connector as well. So if you see here, there's a sink design that goes around the connector space. So we try to avoid the connector sticking out from the surface. While it might be subject to breakage when you accidentally hit it, so we want to protect the connector also to make sure that it can be protected from any mechanical shock. Other system, this is a control unit, which everything that I was telling you earlier needs to apply as well. Okay. Here, I'm just going to show you some demonstration of all these connection systems in the market right now. So one of them is this one where a connector sits below the battery and then you don't have a cable connection here. You just, in this video, will show you clearly where a depleted battery would just be simply inserted in a charging cabinet, and then you can get a new freshly charged one. So if you see that connector right there is similar to the connector that goes into the vehicle. Okay, so that one and this one are a little different because the connectors are uh, comes with cable. So that one earlier doesn't have cable. So you can see in on below the seat, we don't have much of a finger access. So I'm going to show you later what designs can be considered to be able to remove these connectors properly. This is another example of how a cable swapping station can be used. Okay, in the market right now, there's this where a battery, depleted one, can be charged in this charging station using a cable connector insert and then just get a freshly charged one. It happens in a few minutes. Of course, connectors, once your capacity and the motor power are increasing, you need to have a higher current carrying capacity, which then leads to a bigger connector. So this one is a bigger vehicle having larger batteries, as you can see right here. Okay, just some of the examples. And as you can see, there are lots and lots of deployments about these charging cabinets around different countries already. So many people are handling it differently also. So we need to make sure that the mechanical reliability of these connectors are very, very good. So different kinds of testing to see and make sure that they are performing very well in the field. We do this also to design a connector where you can handle it very easy by hand, okay, with a design of an overmold specifically for that. And these are other examples of connectors that has a different connection way. So this is a twist lock design. This is a charging port, which is then the charging port connected inside goes to the battery, which is located under the seat. And some more examples here. This is another different design of a charging port with those finger access tabs right there. And if you want to have an extra battery that you can charge at home, you'll be able to do that using the provided charging brick. Okay, the connector that I was telling you about earlier, under the seat, we don't have much finger access. So a tab where you can unlock the connector only using one finger is greatly beneficial for these types of scenarios. Okay, so if you can see, there are lots of different kinds of vehicles right now. Different applications, also different usage and use cases um, are currently used, like wheelchairs and use for recreational services on waters, things like this. So a good connector that is rugged and waterproof is beneficial for use in this type of vehicles, which are used mainly outdoors. So yeah, thank you very much. These are just some examples. I hope that you got a lot from my presentation. I'm going to pass the presentation to my colleague, Lily, so that she can let you know more about our company.
Thank you, Don. So I will share my screen. Yeah, good afternoon, ladies and gentlemen. My name is Lily. Please allow me to do a brief introduction of Chogori Company. So in Chogori, our mission is to bring inspiration and innovation to sustainable energy. The vision is reliable green connections. Our manufacturing facility spans 44,000 square meters, and we are a team of more than 1,000 members. The production capacity is 2 million sets per month, and we operate from 3 strategic production sites located in Dongguan, Shenzhen, and Thailand. These locations enable us to efficiently serve our global customer base. So next page is about our talent factory. Yeah, this is our talent factory. It's located in Rayon province, and the capacity is 500,000 sets. There are 25 production lines. The location here is about 1 hour drive from Pattaya. So I'm going to talk about the global distributions. In Shenzhen is the headquarters, and Chogori Dongguan, Chogori Thailand are production sites. We have another R&D office in Luoyang, which is also located in China. The others, like Chogori Shanghai, Chogori Asia in Singapore, Chogori India, Chogori Europe, Chogori Canada, and Chogori USA are sales offices. The last part is about the milestone. So, Don, please go to next page. Yeah, thank you. So Chogori was founded in 2007. The name Chogori came from the second highest peak in the world. And in 2008, we provided a lot of connectors for the LED scroll in the opening ceremony of the Beijing Olympic Games. In 2010, we provided the connectors for this LED screen for the Shanghai World Expo. And in 2013, we implemented the Toyota's lean manufacturing. In 2014, we led national street lamp interface standard in China, and we gave the patent out since it's a national standard. In 2016, we obtained the IATF 16949 certification, which is a must for auto industry. And in 2017, our high current contact got the Germany invention patent. In 2019, this year underscore our commitment to global distribution. Also, in the same year, we provided a lot of connectors for the LED screen of the Burj Khalifa Dubai. And in 2022, we officially launched our Dongguan production site. And we also provided a lot of connectors for the LED screen of MSG Sphere Las Vegas. Last year, we operate our talent factory. In the same year, we adopted the Black Blot PMTK methodology for our product management. So the business in the company now divided into 4 product lines. One is electric bicycle, the second is electric scooter, and the electric motorcycle. The third one is emerging lithium, which includes those garden tools, energy storage, and so on. The fourth one is outdoor electrics, including those LED lights, GPS tracking, and smart water meter, and so on. So that's a brief introduction of our company. Thank you. Over to Priyakshi, Amit.
Thank you, Lily. And thank you, Dominic, for this comprehensive presentation around connector solutions. Of course, if there are any further questions, Team Chogori will leave an email address in the chat. So any further questions or deeper technical discussions can be initiated at that email. We will now move on to the very interesting part of today's event. And I would request the moderator as well as the panel members to please switch on their cameras. Oh, sorry, I just realized my camera has been off. So to switch on their cameras and we'll just move on to the panel discussion. So just setting a bit of context before I hand over to Amit to moderate this. So, as all of you would know, that maximum around 90% of EV sales in India comprises of light electric vehicles, mainly two-wheelers and three-wheelers. And going forward, let's say even in 2030, the light electric vehicles are expected to make up to, let's say, 50%, sorry, 80% of EV sales. So, but today, if you look at the industry in terms of EV charging connectors, though we have standardization, of course, in four-wheeler space, but the Indian two-wheeler industry is quite spread out in terms of different charging connectors. Different OEMs currently use more than 10 different kinds of connectors. And towards standardization of DC charging, Type 6 and the Ether connector are the two primary efforts that we see in the industry. So in this panel discussion, we'll try and explore the need for standardization. What problems can it solve? Do we even need to push for adoption of a particular standard? What are the pros and cons, and what are the challenges? So to take us through this interesting discussion, I would request Amit to please take it from here.
Thank you. Thanks a lot, Priyakshi. Am I clearly audible, right?
Yes, Amit, we can hear you very
Thanks
well.
a lot. Okay, so first, I would like to thanks Dominic and Lily for laying the foundation for this webinar and the panel discussion. So by giving us the basic understanding of connectors, which was very tactfully not just limited to charging connectors, but they also captured, battery connectors and motor connectors, which was quite insightful, right? And with that, I would like to give a warm welcome to our esteemed panelists and audience to today's panel discussion, which is a very vital topic, I believe, in today's scenario, which will capture connector standardization efforts which has been made in India with respect to two-wheeler and three-wheeler. So as we accelerate towards a future which will be probably dominated by electric vehicles, the importance of standardization in EV infrastructure cannot be overstated, right? And I strongly believe that standardization not only ensures compatibility and convenience, but also safety and efficiency, which make things easier for OEMs, for users, as well as the service providers to adopt and well as to adapt to the new technologies seamlessly. With that being said, that we are aware that around 90%, close to 90% of sale in India typically happens with electric two-wheeler and three-wheeler in a electric vehicle segment. So let us delve deeper into the efforts that has been made so far in this direction, along with the technological advancement and strategic alliance propelling this movement. So my very first question is, this standardization journey is to Mr. Anirudh Amin. Anirudh, if you can let us know why as such there is a need of standardization of connectors in particularly EV two-wheeler and three-wheeler. And along with that, what problem the standardization can solve in a longer run? Over to you, Anirudh.
Right. Thank you so much. Thank you so much, Amit. Thank you so much, everyone, for joining in. So in terms of standardization, see, basically the whole reason why we need standardization is, for the mass adoption, right? This both applies to smaller companies as well as large organizations to have, standard products when it comes to, connectors being the most primary, uh, you know, checklist, I would say, which is there for charging, because in terms of EVs, charging becomes one of the most vital equipment as part of the whole vehicle, right? So what we have been seeing working with multiple charge point operators and EV OEMs, see, there is always a cost associated to, setting up the charging infra, right? And then there is a challenge of, being the chicken and egg situation, whether the vehicle comes first or the charging comes first, right? To solve that, basically, the charge point operators are pushing a lot to set up the charging infrastructure. Now, if you look at the four-wheeler charging market as well, earlier we had seen in the market that, GBYT or DC001 chargers had been put up across India, but then, the mass adoption was more towards CCS2 chargers, right? So there was a downfall in, both the charger sales as well as the utilization rates for DC001 chargers, which again, kept the charge point operators on the back foot that, whether we invest more onto this charging infra or not, right? Same thing is what we are looking at, getting into this two-wheeler and three-wheeler market as well, with these latest proprietary technologies also coming in for the three-wheeler as well as two-wheeler market. And with these loaders that have also come in, there are multiple standards that have been set up. So the biggest challenge that we are facing right now for the standardization of these vehicles, both from fleet operator side, the charge point operator side, is the utilization point of it, right? Because most of the two-wheelers or three-wheelers, now if you look at the whole segment of these two-wheelers and three-wheelers, it's either passenger vehicles or it's used in B2B fleets in terms of delivery people who are using it. So the whole concentration of the EV charging is more in residential or in warehouse places where there is distribution or a hub and spoke model that is going on. Now, for any particular hub which has a lot of inflow and outflow of logistic guys, there has to be a standardization. Otherwise, we keep repeating the charging infra again and again. And as everyone knows, there is a shortage of power, so we can't just keep repeating this charging infra again and again. So that is both associated with the constraints on power as well as the investments that have been put up by a lot of people against all of these multiple standards that have come in. Though we realize that each and every standard that has come in, or each and every connector that has come in, has both pros and cons, but we have to consolidate the market towards having at least one standardized mass adopted protocol which can be interoperable for both two wheelers, three wheelers, and the mass market. This is to reduce again the investments that have already been put up into this infrastructure. Otherwise, we are at what, phase 2, entering into phase 3. By phase 6, I think we there is a constraint as well on the subsidies that have been put up for setting up these infra, because most of the funds utilized in phase 1 was for infrastructure setup, which was DC001, which has no use as of now, apart from one or two vehicles that have been set up, right? So the biggest hurdle that we see for the industry for standardization is the investments that have been put up, both on R&D as well as to get the whole infrastructure set up for the charging segment. So that is, I think, one of the biggest aspects that we should look into, when it comes to the charging infra side. Secondly, on the manufacturing side, again and again, we have been seeing that there are a lot of changes that keep happening in standards, and which also impacts on vehicle OEMs, which then again impacts the charger manufacturers to keep adopting to these increasing proprietary networks that come in. So on both the sides, for vehicle OEMs as well, it is a supply chain issue. If you get into proprietary connectors and protocols, it is difficult for getting the whole supply chain set up for both the OEMs as well as the charger OEMs, right? So I think with these two or three issues, I think there should be a consolidation of market to getting at least one or two standards which are there, which are mass recognized. In terms of certification, I would say all of them are certified by the Indian government, right? Whether it is proprietary or whatnot. So you may get into safety standards and all those as well, but there has to be a mass adoption angle as well into this, where both the industries have to flourish and the investments have to be in the right place. I think this is this is where the standardization would actually play a big role for the mass adoption.
Thank you for those insightful comments, Mr. Anirudh. Right, and I also believe that standardization will not only bring the convenience from a user point of view, but by promoting interoperability and all those things. But I think the OEMs will also gain a lot of that, because it can turn into a quicker and mass adoption of both two-wheelers and three-wheelers when there would be a standardization of infrastructure and connectors. Right, and being continuing into this topic, I would like to bring Dr. Dev Mukherjee into the conversation. Dr. Mukherjee, being an industry expert and having a rich experience in automotive and clean energy domain. So my question to you is, Doctor, what do you believe which all stakeholders are required for standardization as such, whether it is Niti Aayog, Ministry of Heavy Industry, Bureau of Energy Efficiency, Electricity Board, etc.? And what, according to you, these roles should be defined and these players should come into the picture for driving this standardization?
Yeah, thank you, Amit, and good afternoon, ladies and gentlemen. It's a pleasure to be on this panel. And Team Chogori, it was a very nice presentation, learning about the technology behind a very successful product and your brand. Chogori today, I think, is synonymous with connectors, and it's a great company to work with. So I think as the industry evolves, I think these are all part of the evolution, the standardization, the whole regulatory aspect of it, which takes into consideration various expertise and experiences of the past. IC era vehicles also, went through a lot over last, 100 years or so. Now, EV being a new industry, it has to go through a lot of evolutionary cycles. I believe that in India, particularly the two-wheeler and three-wheeler case, these two are the, as we all know, the success stories of electrification of automobile in India. I think the inflection point has reached now, and I see that going forward from here, the growth is going to be exponential in these two form factors. At the same time, in India, the standardization happens, in more or less in across the industry. If I cut across, and then we see it is either through the regulatory mechanism, government imposes something and then makes sure that people follow it, or it happens through mass adoption of an industry leader. For example, if Suzuki brings in something today, obviously it will become a industry standard, something like that. So my view is that EV being a altogether new industry across the globe, I think a lot of experiences are we are getting used to EV, particularly in India. And in the case of two-wheelers and three-wheelers, there are several specific use conditions that the manufacturers, all of us, in the battery maker, the BMS maker, the motor controller, and the other peripherals like chargers, charging connectors, etc. All of us are learning. So, in India presents a lot of a unique set of challenges. Also the opportunities, because we have a lot of temperature variation here, from 5 degree to 55 degree across the country at the same time. Then we have huge, dust problem in certain areas, and we have a lot of monsoons and rain, etc. So I think the whole the environmental conditions in which a vehicle operates, or any part of the vehicle that operates, are quite unique, and they have to be taken into consideration while we design these specifications and we design our products. So what I'm essentially saying is something which is successful in Europe or parts of China may not be successful here. And that, we need to keep this in mind. Many European makers, tried to do copy paste here, and as we know, not many of them succeeded. Why, Suzuki and Hyundai succeeded in a big way is that they were able to understand the user needs, understand the environment in which we operate. So that is where I think the role of the industry, first of all, comes in, and all the stakeholders within the industry. See, as an OEM, I don't design connectors. That is the job of somebody like Shogori. I only buy connectors. My job is not to design. I don't know, what goes into the designing of the connector, and how much current it can carry, or how much resistance it offers, and what is the life, etc., etc. My consideration is it easy to use for the user? Is it compatible? Is there interoperability? And does it have the life that I give to my customers? And also then there is a cost element to it, right? So I think this is what we from the industry bring to the table. Now comes the role of the regulatory bodies like BIS and the Central Electricity Authority and the ministry, etc. So they will have to put in the regulations so that the operations are safe, smooth, and easy to use, etc., etc. And everybody follows a set of standards which are usually global in India. We generally are quite aligned with the global standards. So I think this is where the role of the regulatory bodies come in. And then comes the question of enforceability. This is where the government comes in, and in India being a federal state, the center as well as state governments have their roles cut out. So I think this is how, and then the additional inputs, this being a new industry, a lot of technology changes are happening. A lot of research is being, for example, battery technologies are evolving at a very, very fast pace, right? So that is where the role of researcher, academia, the people who are experts, and the scientific community comes in. So my view is that it has to be a combination of all of them, get all the ideas onto the table. The academics can say that this is the best technology, and this is how it could be designed in a better way. For example, whether it is design or material or enhancing the performance, enhancing efficiency, etc. Then the government regulatory or the policy think tank, like Niti Aayog, etc., can give their view, if it is workable, scalable, in Indian conditions, etc. And BIS can then standardize it and put it in the form of a specification which could be applicable to all. So I think this being a absolutely new industry and such a with so much of massive transformation happening and having a very, very wide impact in all our lives. A change of fuel is not a small thing. The entire paraphernalia of delivering fuel from the refinery to the end use gets impacted. So, and the same thing will happen in electricity also, from generation to the charging will get impacted. So I think this is where a very, very cohesive sort of effort is required to standardize, to make it easy to use, and also make it a very efficient and effective system, so that everybody sort of adopts it. I mean, these are my thoughts.
Excellent insights, Doctor. And I also strongly believe that to accelerate this transition of standardizing the complete EV ecosystem of two-wheeler and three-wheeler, all the stakeholders shall come into picture and join hands together, whether it is government bodies or regulatory bodies, OEMs. Even the CPOs can add value into this by giving insights of what type of utilizations we are getting on what type of standards, along with the convenience feedback that they are getting from the customers. So moving forward to Mr. Kelvin, sorry. Mr. Kelvin, as being a technical expert, we would like to understand the technical requirements for standardization, and along with the challenges and opportunities that you see in the standardization process. If you can just throw some light on that.
Yep. Again, thanks, Amit sir and Dr. Deb for the kind words, and then Anirudh as well for all the various insights. I mean, we are very appreciative to India, where we started as early as about 2016, 2017 into the market, start to talk to different customers, the vehicle assemblers, the charger operators, battery manufacturers. So we learn a lot in the process, helping us to fine tune all our internal processes. As you saw Dominic's presentation, we are automotive certified. So everything that we do are based on a US car standard. So that is a very stringent automotive criteria. Then more things start to add on to us when different customers ask us about, okay, we need to use the connector in a certain bending radius, certain things like that. So that sort of forced us to improve on a lot of all these different factors. Today, yep, you're right to say that there's yet to see some kind of a standardization. And I think Anirudh also mentions that mass adoption is going to be one of those key factors. If you have a very big player that comes in and then just sort of rock the boat, and then maybe things will go. But from the different customers that we work with, the B2B space, the B2C space, everyone has a different requirement. In terms of the power, we have those that we use in scooter categories. We got products that we can apply for those without cables, like what Dom presented through Sun Mobility, that we have served them over the years based on the solution that we have. Then we also have the motorcycle categories where the power goes up. And then the best part is, okay, so certain things start to become a standard, the IEC standard, the Type 6. And we also internally discuss in terms of the development, because the IEC is a global standard. So and it can be applied globally. And that's where we went in to develop the slow charge gun and The commercial gun, we're thinking about a few things, but we will also launch it within this year. Because there are different requests coming in from different customers that I talk to. There are those that is, because the standard itself, I mean, all of us know very well, is a 120 volt DC for 100 amps. And people are thinking to bring this higher to 125, to bring this higher to 150. And I even have requests, can this standard meet up to 180? Things like that. Eh? So as you know well, if your voltage goes up, your current goes up, you end up a lot more losses, heat generation, you're going to face with a lot of resistive losses in cables. There is a lot of different challenges right now that I'm not even sure if the infrastructure side can actually take it. These are some of those questions and doubts that we have internally. So me and my product team, we've been discussing again and again and again and again. So, and then we also getting somebody within the group I saw just now ask a question about, do we have high voltage interlock loop? Yeah, we do. We design our own sockets. We design the plastics, the housing around it, so that we can better control all the tolerances with regards to all the other parameters, mating cycles, contact resistance problems, heat generation issues. We work to make sure that we fully understand all the formula inside. So people are also thinking, that customers thinking about having very high voltage, more than 400 volts, 200 amperes for battery outputs, for motor controllers, things like that, in which we have products that we can do. And people pushing the type 6 into this power range, 150, 180 ampere, things like that. And also customers thinking about, okay, is this probably the smallest form factor possible to go into a two-wheeler, a three-wheeler, and a four-wheeler? And that they're talking about the NACS standard. And then whether or not that particular standard can incorporate CAN bus, because by comparison, in terms of what we're looking at, CCS, and then you sort of step it down, it is indeed a really small form factor to fit into a two-wheeler. So for us, we are bottom of the food chain, thinking about the to serve the needs of the market, the requirements. We are capable to develop anything within our factory here. We don't have an issue. How the standardization will be as it slowly evolves, this is the part that I'm still cracking my head very, very hard about how this may actually go. So this is the part whereby I don't have definitive answers. And then we have Anirudh sir and Dr. Depp in this call. Maybe you can give me some insights further than we can do anything. It's just a matter of what is there a need? Is there a genuine need to push the power to that level? This is the part whereby I have a very big question mark. Right, Amit sir?
Thank you, Kelvin. So in continuation of that, Kelvin, I would just like to put across another question. Do you feel some sort of adapters can solve the problem of, let's say, CCS to Type 6 or CCS to Type 7? Are some sort of developments are going in that directions as well when it comes to adapters?
Okay, currently, throughout the customers that we work with, we have a lot of different solutions that even for TVS, just be very open, that uses some of our current connector solutions.
Understood.
And then and there are also there's a lot of different requests coming also at the motorcycle categories. That we have another range of products, the Banga, that is carrying up to 80 amperes, 100 amperes. That is more on the motorcycle category. And then now we have the Type 6 that I think possibly as we move forward, maybe more of the premium bikes or the scooters will be progressively fitted. This is the current trend at the moment. I mean, like I mentioned, there's no specific one that that says that this is the way to go. This is what the market will very definitively be. So no, we have no idea
Understood.
how
Understood.
things is going to evolve. Yeah, we have no idea.
Thank you, Mr. Kelvin. Now I have a very interesting question on a broader front, and I think this is open for all three of you, right? Which is quite buzzing, specifically in India for two-wheeler and three-wheeler, which is like a comparison between Type 6 versus Type 7 connector. When it comes to what do we say, ease of convenience, ease of integration, safety, current and voltage limits. So, Anirudh, I believe you have been handling all sorts of player, right? Whether it is Type 6 and Type 7. So let us start with you if you want to put your thoughts on which one is better or which one has an edge.
Right. Thank you, Amit. So I think there is, I believe there's no rivalry between Type 6 or Type 7. I think it's just a user choice or a brand choice that has come in. So potentially, what we are looking at as an adoption challenge, or why people have got into Type 6 and Type 7, is more towards, the brand equity that these guys have. Essentially, what's happening in market is, in at least in four-wheelers, it's much more easier because there are a lot of charge point operators catering to the four-wheeler market. Whereas in two-wheelers, what we have started seeing is there are a lot of brand promotional schemes that have been given by the two-wheeler manufacturers, where people can charge their vehicle for 1 rupee for the first year, and all those things have come in. Where we have seen interoperability as a topic that had also come in. So what essentially happens for players like Ether and Hero and all of these guys, they have given I think there are some promotional schemes or packages that they have, that for the first year you don't pay for your charging, it's included in your subscription models and all those things. See, this becomes a challenge when you have a proprietary ecosystem in both software and hardware, to expand it and have these promotional activities to be availed by other charge point operators. When you consider other players in the market who have adopted Type 6, they are more open towards having the charge point operators set up public charging infra, and then people just paying for whatever they charge. That is not the case. I think in Type 6 also there are players like Ola and all who don't support interoperability as of now, right? They are still on Type 6. So that is again an issue that what we are trying to achieve is, though we have standardization of Type 6 adopted by one part of the two-wheeler automotive OEM, it is still not interoperable. It is standard, like everyone is using Type 6, everyone has the same protocol, but it is not interoperable, right? So the mass adoption, when it comes, it's not just about standardization. Though you have standardization, I can't take my say a torque to charge at a Ola charger, right? That doesn't happen. So ultimately it is not solving anything for anyone as of now.
Right.
Me as a user, driving towards a public charging station and not able to charge my vehicle is the biggest issue, right? And also, as Kelvin was discussing regarding high power charging, right? Again, I would like to circle back on the issue of having power availability to all of these users. Right? We are not able, with all of the installations or deployments that we are doing, we don't even see a spare power of 10 kilowatt available in most of these societies, right? There is an issue for people to charge their vehicles in terms of getting the power available for charging, right? So we have seen this in four-wheeler market also. This is not something new, where we have seen 60 kilowatt chargers only putting out 20 kilowatts, because the input capacity is only 20 kilowatts. So even if I put up a 60 kilowatt 120 kilowatt charger, it is only giving me 20, which doesn't solve anything in terms of having high power charging. So whether it is Type 6 or Type 7, all these have to be standard as well as interoperable. It is not just the standardization that also has to come into picture, and all of the partnerships, when you look at the larger players in the charge point operation market who have come into this segment, they have their own set of networks, right? Though they have CCS2 chargers, but again the networks are not interoperable, right? We are not able to then again we come back to the same issue, downloading multiple applications, having multiple wallets and all these things. So even though the connectors are standardized, they are not interoperable with them. So ultimately there is still an issue of having all of these vehicles being charged in each other's network, right? So today, if I look at Ether versus any other Type 6 charger, both have to simultaneously develop their own infrastructure in terms of charging. So along with selling the vehicles, they also have to develop the charging network, because I can't just walk up to Ether and say that I'll set up the charging infra for you, like other charge point operators are doing it as a public network which is being established. I can't just go to these proprietary players and say that I am ready to put up the investment and get the network up and running. So even though they are following specific standards, it is not going to be type 6 versus type 7, but it has to be mass adopted and interoperable as well, not just on the standardization part. So and this is not just, as I said, it is not type 6 versus type 7. Even type 6 are not compatible with each other. So ultimately that also has to be looked at very carefully when it comes to the standardization discussions that are going on, because ultimately if the whole aim of having this is interoperability and ease of access for the end consumers to charge their vehicles, right, then basically we are not solving that particular pain point. So I think, see, in terms of standardization, what I believe is for the end user, it is basically getting the access to charging, right? For them, it doesn't matter, where they charge their vehicles, but it is more towards the accessibility of these charging networks that they have. So in terms of standardization, one part is getting the connector standardized, where a charging station would connect with my particular vehicle and then start charging. And on the interoperability side, it is more focused towards getting the access to that particular network. So as I said, Ola and Torque both have type 6, but either of them can't charge at someone else's network. That becomes an interoperability issue and not a standardization issue, right? So something that in similar industry, what had happened with us on UPI gave a baseline for everyone to start exchanging funds with the same protocol, right? So something similar is what I think BCA is trying to also achieve with UEI, where all these networks could be charged by the same network layer, where all of these Olas and all could be charged like the interoperable which is being done between type 7 Aether and Hero, where Hero can still charge at a Ether platform, and then likewise on the other side. So I think that is what is being done by BCA for the Type 6 network, which does solve the interoperable issues with the other OEMs that is there in the market right now. So I think it is not just the connectors being standard, because I think we are more focused towards being connector standardized, but even the standard connectors are not able to charge with each other. Then again it becomes redundant for these systems to again come into picture. And still the government can push up having this like CCS2 being pushed by the government, like Dr. Deb had suggested that enforcement should come in, that all of these networks should be interoperable. I think as of now there is no mention of these DC charging, at least in our standards for EV charging. There is a standardization for LEV AC, where anyone can just plug and charge their vehicles. But at least for DC charging in two-wheelers and three-wheelers, there is no standard as of now that has come in. So I think enforcement would also play a lot of role when it comes to these interoperable solutions.
Continuing what Anirudh was saying, that I also strongly believe that the whole purpose of this standardization thing, whether it is connection, whether communication protocols or other aspects, the purpose is to give the ease of utilization to the end customer, right? And providing interoperability. Obviously, these connectors, the standardization which are meant on connectors will provide safety point and other aspects as well. But if it's not delving directly and focusing towards the interoperability thing, then the whole purpose would be dissolved, I believe. So rightly said, Anirudh. Now, I would like to jump to Dr. Deb now. Dr. Deb, from OEM point of view, if you can just highlight 2 or 3 things probably. What do you, how do you select a particular type of connector when it comes from customer point of view or other aspects?
Yeah, you see, the decision to go for a particular connector, it all depends on the design. It is decided on the design stage, and also working together with the battery supplier. So it's part of the, you can say, the energy pack of the vehicle, the whole battery, charger, and then the connector is obviously a part of it, and the ease of use, etc. So I would say that there are 3 or 4 broad criterias in which an OEM, what an OEM looks for, and then he works together with the suppliers and tier 2 supplier, etc. So one is obviously the design criteria. what is, how robust is the design, and does it meet the design user expectations, etc. Like Chogori showed their product profile, and they have very robust materials. For example, they also, in terms of using right materials for the cables, etc. So that's the whole thing about the design criteria. Does it meet a particular standard specs, and also the users expectations? Then comes the performance criteria. As I said, in India, performance can change very, very widely across India. If you are running a vehicle in Rajasthan, temperature of 50 plus, to somewhere in Jammu Kashmir with 5 degrees, so there could be huge variation. And drive cycle is different, method of driving is different, and driver to driver there are a whole lot of changes and issues. So that those certain performance criterias are expected when I sell a vehicle to my user. And this being three-wheeler, being a commercial vehicle, it has to earn money for its users, right? So particular mileage is expected, for example, particular speed and climb on the gradient, etc., are expected. So same way, the charging, when it comes to charging, everybody wants the vehicle to be charged like you fill petrol in your vehicle. So obviously that is the best case. You drive into a charging station, you plug in your vehicle, and there you go in 5 minutes. Okay, so that's more and more fast charging, rapid charging, etc. All these technologies are coming. So as I said last also, that the whole technology is evolving very, very fast. So this is where the performance criteria comes in. What have we?
Right.
Performance means it is the performance of my product vis-a-vis what it is intent to give. The design intent versus the actual. So if it is supposed to charge in 30 minutes, so am I able to charge in 30 minutes or not? It's simple.
Right.
So this is where we choose whether the supplier has met those criteria, does he have the capability, etc. Then third are the intrinsic benefits, like the ease of use. For example, Kelvin mentioned about the bends and the use, and these are all repeatedly used, and every driver, every user uses its own way. There are a lot of misuse, abuse at times, etc. So connectors go bad. We have seen handles breaking, the plastic material coming off, etc. So those are the issues wherein the expertise of the supplier comes in. And last and also the life. This is a product like charger and connector which has to perform day in and day out, every day. If you charge 3 times a day, every time it has to work. Otherwise you have a problem. So the fail safe is the most important criteria. And also it has to perform in a very, very safe manner, so that there is no accident or fire or anything like that. So I think these are the important criteria for us as an OEM to evaluate. And last but not the least is the cost.
Right.
Cost is everything has to be packaged inside the cost targets. So I think it's very important that I believe that technology is the solution for all your problems in life. Technology can solve all of these issues, whether it is a design issue or a performance issue or a life cycle issue. If you have the right technology and you plug in the user side requirements into it, those user side requirements are sometimes very, very specific. For example, I gave you the use case of India. So you plug in the user requirements, then you tailor make a solution. So that is what we look for in a supplier.
Thank you, Doctor, for those insightful comments. And actually, now we are running out of time. Otherwise, I would have loved to explore more about this topic. Probably we'll do a part 2 of this session if Priakshi allow, maybe in coming days, right? And thanks a lot for all three of you for joining in and giving us valuable insights on this subject. Kelvin San, Mr. Anirudh, and Dr. Mukherjee, thank you once again. And over to you, Priakshi, for Q&A round.